Hi, this is Colin here from Grade A Computer Science, and welcome to this presentation on the Fetch, Decode and Execute cycle. Now in this video I'm going to be breaking down the Fetch, Decode and Execute cycle, so you'll be able to see what's actually going on, how data and addresses move around within the CPU, within the different registers, and you'll be able to follow along with it and hopefully understand it and use it in an exam. Okay, let's get into it. Alright, so here we are. What have we got? We've got the registers, so these here. So these here are the registers. We've got the accumulator. We've got which is the main register for doing logic and arithmetic operations. We've got the MBR, which is the memory buffer register, also known as the memory data register, and this is the register where data is retrieved from the address location in memory and put here. So then we've got the memory address register, where address information is buffered here to move on to another place. We've got the CIR, which is the current instruction register. So this is the register with the instruction that's currently being carried out. And then we have the PC, or the program counter, which is the address of the first instruction here. So you can see that it's actually set to 1 and it's waiting to start the program. What else have we got? We've got memory here. Okay, so we can see the memory. Now this memory, in fact, these two memory items are within the same memory block. So you've got 1, 2, 3, and then there's lots of memory between 3 up to 34. Then this other memory location, 57 and 88. These are all different memory locations. You see there? These are different memory locations within the same piece of memory. 1, 2, 3, 34, 57 and 88. So these memory locations will be addressed in order to get the data which is within those memory locations. And you'll see here what we have. For instance, if we look here, in this one here, we've got the memory location 1, and that contains an instruction. But over here in memory location 34, this contains some data, okay, which actually is in keeping with the von Neumann method, where you have both the program and the data in the same memory. Okay, let's move on. So let's see what happens. What we've got here, we're starting with the program counter is set at 1, and in this case now the address of the first instruction is copied from the program counter to the memory address register. So that's the first thing that happens. And as we go through this, you'll see how this repeats. Now, the first instruction is read into the MBR, into the memory buffer register. So we know that the first instruction was in location 1. So we go to location 1 here. Okay, and then we find that this is the instruction that's in that location. So that instruction goes into the memory buffer register like that. So that's the first part. Now, the first instruction is then copied into the current instruction register. So we see here that the instruction in the MBR is then copied into the current instruction register, waiting to be executed. And you can see here, at this point, we're still fetching the instruction from memory. Okay, the next instruction, the program counter, is now updated to point to the next instruction in the program. So we increment the program counter by 1. Okay, so that was previously 1, it now becomes 2, and in this case the program counter is also, you can see that the program counter is now updated. Everything else stays the same. Now, in this part, the address part of the current instruction, so the address part of the current instruction, which is here, is placed in the memory address register. So this is the address part. So it's saying load 34, or load the accumulator with 34, or at least the contents of the memory location whose address is 34. So that will go to here. Right. So now the contents of the location whose address is in the memory address register are loaded into the memory buffer register, or the memory data register. So we know that 34 was loaded into the memory address register, and when we go to the memory address register, we can see that the data is 28. So these are the contents of the memory address register. This is the contents of the memory address register. And what we do is we take that data and we put it into the MBR, into here. Now, the contents of the MBR, the memory buffer register, are now copied into the accumulator. So now we're loading the accumulator with the contents of the memory buffer register. So that goes here like that, from the memory buffer register into 28. So that really concludes the first part of the instruction. Well, that concludes the instruction itself. And you can see here that we're actually executing the instruction. So that means that the instruction is now executed. Let's move on. Now at this point, the status register will be checked for any interrupts. Now interrupts are where the processor will receive signals, control signals, that mean that, for instance, a printer is wanting to do some printing, or there may be a problem with the some of the electronics, but it's basically a check to make sure that there's no one else or nothing else that's looking to get some service from the CPU. That's what the status register is checked, is all about. So now we're going to do the second instruction. And again, it's very similar to the first instruction. So in this case, the address of the second instruction, so that's here, is copied from the PC to the MAR. So it's copied from the PC, from the program counter, to the memory address register. Then the second instruction is read into the memory buffer register. So that second instruction, which was in memory location 2, is now read into the memory buffer register. There we go. The second instruction is now copied into the current instruction register. So that second instruction, so here it is, it was in the memory buffer register and it's now moved to the current instruction register. And of course the program counter is now updated to the next instruction. So we now increment it from 2 to 3. Okay, ready for the next instruction, which of course will be here. See that? And you can see here that we're updating the program counter. Now, the address part of the current instruction is placed in the MAR. So again, we look at the current instruction that we want to execute, and we're looking at the address part of that instruction, and we're going to place that address part into the memory address register. And having placed it into the memory address register, the contents of the location whose address is in the MAR are loaded into the MBR. So the contents, this is the memory address register here. Let's just get so here's the memory address register, and those contents, so we know we're just here and we find the contents of that address register, which is 62. We take that 62 and load it into the memory buffer register, the memory data register. So having done that, having loaded the data into the memory, the data from the location into the memory buffer register. The contents of the MBR are added to the ACC. Remember that the instruction was to add the contents of 57. So here's 57, the address 57, the contents of which are 62. We copy that into the MBR, and that is then added, 62 is then added to the accumulator. So we add plus 62. Now remember that we had 28 here previously, so 62 plus 28 would give us 90. So that 90 would be the new contents of the accumulator. So that's the next instruction completed, and of course we now check the status register to make sure that there aren't any interrupts before we move on to the next instruction, which of course we're going to look at the program counter to find where that instruction is going to be. So of course the address of the third instruction is copied from the program counter into the memory address register as before. The third instruction is read into the data, into the memory buffer register. So here's the third instruction, the address of the third instruction. You can see here that we go to 3, and now we're going to use the contents, which is this instruction. This will now go to the memory buffer register and be placed there. Okay. And then of course that's going to be moved into the current instruction register, but we'll see that in a second. Okay, so the third instruction, as I said, the third instruction is now copied into the current instruction register, and now the program counter is updated to point to the next instruction. So the program counter, which was 3, is now updated for the next instruction to come along. And then the address part of the current instruction in the current instruction register, that will be placed into the memory address register. Okay, so that's the address part of the instruction placed into the memory address register. And of course now we're going to use that information, this information, to retrieve the contents of the data that we need. So going forward, so the contents of the accumulator are copied into the MBR. So what we're doing here is to store the actual command is to store the contents of the accumulator in 88, or memory location 88. So what happens here is that we're going to the contents of the accumulator, which is here, will then be copied into the MBR, which is here, and then the contents of the MBR, which is here, are copied into the memory location whose address is in the MAR, or is in the memory address register. So the contents of the memory buffer register, we know that the memory address register is 88, so we're going to save the contents of the buffer register into the, it's going to be here, let's go this way, shall we, into here, that. So now the contents of the memory buffer register, which is here, are copied into the memory location whose address is in the memory address register. So we know that the memory address register is here. We know that here is the memory address register, and that's the address. So the contents of the MBR are then copied into this register here. So that becomes, previously it was 135, but now it becomes 90 because the contents have been copied from the MBR into the memory location 88. And of course, the next thing, having completed that instruction, the status register is checked again for interrupts, and that would essentially conclude the cycle of those 3 instructions. Okay, so what have we done? What we've done is to look at the fetch, decode and execute cycle. We've looked at how the CPU sends addresses to memory and fetches data from the memory using the addresses. The decoding cycle is the decoding process where the instruction is decoded into the opcode and the operand. And the operand is actually the address which is moved into the memory address register. Once we know where the instruction is in memory, the execution of the instruction will occur, and then we check the status register. And then it all starts again. So the CPU sends addresses to the memory, fetches the data from the memory, decodes the instruction into opcode and operand. The instruction is executed. We check the status registers, and it all starts again. Well, so that's it. I hope you really like what you've seen. I hope it's been a good video, and I hope it has given you some great value to help you understand the fetch, decode and execute cycle. If you like what you've seen, subscribe, like and comment on this channel, and give us a visit at gradeacomputerscience.com. Any questions that you have, please put a question to me or leave a comment in the video. Let me know what you think. If anything I can help you with, we're all too happy to help you. This is Colin Baptiste from Grade A Computer Science.